Hello, in this video we will discuss different strategies for integration. By now we've learned many different integration techniques, but one aspect of becoming better at solving integral problems is recognizing which situations to use the various techniques. This requires trial and error. Many times we'll try a problem a couple times before we settle on the correct technique. And this will sound cliche, but the way to get better at this is really just to practice. The more problems we can work in, the better we'll get at them. The way to build intuition is by practice. Here are some features to look for when trying to figure out which technique would be appropriate. If you have an integral that has an inner function, especially if the derivative of that inner function appears somewhere else in the integrand, then U substitution is often an appropriate technique. U substitution is also a good default technique if you don't know what else to try. If your integral has a product, especially when one of the factors is a transcendental function, this is something like sine or other trig functions or a log function or perhaps e to the x. If your integral involves a factor with one of those functions, then integration by parts is often going to be a helpful technique. If your integral has powers or products of trig functions, a lot of times trig simplification is the appropriate technique. You want to do a trig identity, simplify the integral, and go from there. If your integral involves a rational function, generally partial fractions is the best way to solve that problem. Let's look at a few examples. We won't fully solve any of these, but we'll take a look at which technique would be appropriate. If we have the integral of x times sine of x, we have a product, and a product that involves a transcendental function. So an appropriate technique for this problem would be integration by parts. Now let's look at a related problem that just changes one thing. If we have x times sine of x squared. Initially we might think, oh, this would be integration by parts. We have a trig function multiplied by x, but in this case the best technique is U substitution. We have an inner function x squared. The derivative of x squared is 2 times x, which is close to what we've got here. So this is going to be a U substitution, and we'd use the substitution u equals x squared. Here's another example. If we have the integral of sine of x times cosine of x, there are actually a couple different ways that we could solve this integral. One method would be using u substitution, and we could choose u to be either sine or cosine. That's one method. Another method would be to use a trig simplification. There's a relevant trig identity, which is whenever we have sine of something times cosine of something, whatever a and b are, this is equal to 1/2 times sine of a plus b plus sine of a minus b. If we apply this trigonometric identity, then the integrand would become the integral of 1/2, and the a and b in this case are both x, so we'd have sine of x plus sine of x minus x. So this would simplify to 1/2 times the sine of 2x, and we could solve this integral by doing a small substitution of u equals 2x. So a couple different ways of handling this integral. Finally, consider this example. What if we had the integral of 2x plus 3 divided by x squared plus 3x minus 4? This is a rational function, so the technique that would first come to mind is that we should probably use partial fractions, and that would work. If we use partial fractions on this integral, we would get the right answer. However, there is a second way to work through this integral. If you look at the denominator and think of the derivative of the denominator, that's what the numerator is. So in this case, we could also solve this using a u substitution. We would set u equal to x squared plus 3x minus 4. And u substitution in this case is a little bit more difficult to recognize, but if we use u substitution, solving this integral is a little bit easier.